Hello.
Hi, Brijesh.
Yeah, can you hear me properly? Yes.
Yeah, I can hear you.
Okay, let's start it.
Yeah,
So yesterday we have discussed and we stopped at test execution. Yes.
yeah,
Now when we execute it, what happens? We have executed all the test cases, so we need to complete the testing. Yes.
yeah.
So when we have to complete the testing, what we will do? We have to go to that section. So today we will discuss the test completion.
Okay. Are you sharing your screen?
Yes. Okay. I shared it, but we have got disconnected. So today we will discuss test completion. Can you see my screen?
Not yet. Yeah, I can see now.
Yeah, so what is test completion? The activity that collects data from completed test activities to consolidate experience, testware, facts, and numbers. Yes. So as for example, how many test cases, how many requirements, how many passed, how many failed, how many defects we have raised, how many defects are fixed, etc. etc. So activities to consolidate experience, testware, facts, and numbers. So we provide all the informations and complete the testing activity. So what are the major tasks we have in test completion? Create test summary report. Yes. In this report, you will provide the activities you have done during the project with all the numbers, as I said. Yes. You
Yeah,
also need to provide closing defect reports. So as you are closing the project and you will hand over the task to the maintenance team. So what you need to do? You need to close the defects report. You don't need to close all the defects. It's a closing defects report. You prepare a report and provide to the maintenance team. Raise change records for remaining open defects. Yes,
yeah,
change records for remaining open defects. So what happens with this one? Whatever defects are open, you are going to hand over to the maintenance team. So you need to just generate a report of change request. Yes. Next one is documenting the acceptance of the system. So what happens with this one? You are accepting the system. So you need to prepare a report and give it. You are accepting the system. So you need to provide evidences. You say that okay, I authorize that this system is stable and we can accept it. That doesn't work like that. Yes,
yeah,
you need to provide the evidence and document it. This system is acceptable so that we can deliver it and we can start using it. Yes.
yeah,
Finalizing and archiving testware and test environment. So the test environment we have. Yes, we have to finalize test environment and archive it. Okay, this is the environment you finalize and archive, store it so you can use in future. Yes, one by one, all the firmware should be stored, all the versions should be stored. In the end, you have done everything, so you hand over the testware to the maintenance team. Now it is not your responsibility, okay? Whose responsibility? It is the maintenance team responsibility. They will do it. They will do enhancement, they will do change and everything because you have completed the project. So it is the responsibility of the maintenance team. So you hand over everything, the testware, to the maintenance team. Analyze lessons learned. During the project, we might have made so many mistakes, yes?
Yeah.
So what happens? You need to analyze whatever lessons we have learned, what mistakes we have made, and what things we have done in a good way. So we can reuse this technique so in future project we have less issues. Using information gathered to improve test maturity. Yes. So whatever information we have gathered during our test project, we need to use them in future so we can use as a test maturity. Yes. In the previous sections we were analyzing lessons learned. So we learned it. What are the mistakes we have made? So what we have done in here, we have done these good things, we have done these bad things. So from that we can use it. So we can use this for the improvement. If we have made the mistakes, then what happened? We can improve. We need to use that. If we have done good things, then we can use the good things next time. If it is bad, then you know that how we can improve it. So using the information to improve test maturity. Any question?
No.
So the next section talks about the phases of or the levels of testing. So the first level is test planning, monitoring and control. Yes, test analysis and design, test implementation. Yes, execution, test completion. Agree? So these are the phases we have: test planning and control, or test planning, monitoring and control, test analysis and design, test implementation and execution, means test implementation, execution and test completion. So there are 5 levels. At execution level, if you find that the requirements are analyzed incorrectly, then you can go to that phase and restart from there. At execution level, you found that implementation, the test procedures are incorrect, then what you can do? You can go to that. At execution phase, if we have found we have made mistakes with the planning, we need more time, or the planning is incorrect, then you can restart from the planning phase. So this is not fixed. You can start any project, any phase, any time. But you, as a tester, you will not, okay, this is planning, so you just plan. These activities are done the same time even. Yes, as for example, the manager is planning. The same time he might have given you, the test manager might have given you work to requirement analysis and design the test cases. Yes,
Mhm.
so it is not okay. This 1 month we will just do planning. This 1 week we will do test analysis and design. This is third week we will do something else. It is not like that. Okay, you can start anytime and you can finish anytime, but you might be doing test analysis, but some other tester might be doing test execution. So these activities go parallelly. There is a not fixed time box period or duration for this activities. Yes,
Mhm.
but test completion has its schedule. You can't complete when you are executing. When your execution is complete, that stage you can complete. All other four, they work parallelly. Any question?
No.
What are the mindsets of a developer and a tester? So the developer, what he thinks, developer builds a software and the developer thinks the software is of acceptable quality. When the developer built it, what he says? The software is of acceptable quality. It doesn't have any mistake. Yes, there are no bugs, there are no error. The software can be acceptable. What the developer thinks of the software, it will work. The software will work. I build it, so it is going to work. Tend to look for what works. And as a developer, you look for the things which is going to work. Yes. And as a developer, things testers are too negative. What the developers thinks, testers are too negative and pedantic. Am I right?
Mm.
But developers think this way, but the testers thinks is a different way. What the testers think? Let's go. Acceptable quality. Then we will think as a tester, this software contains defects. Whatever quality software you deliver, the tester will find defects. Okay?
Yeah.
So the testers will think whatever quality is there, it will have defects. As a software, whatever quality it will deliver, you will say that won't work.
Yeah.
And you will find it is not working as per the expectation.
Because developer thinks in his own mindset,
Yes.
and even tester will think in a different way, because he has
Yes.
his own imagination,
Yeah.
and being a tester, we will be having own imagination.
Yes. What as a tester? Here we put as a developer that tend to look for what works. As a tester, we look for what doesn't work. Okay. Tend to look for what does not work. We always have tendency that this is not going to work, and we will identify those things which are not working. Things developers are too optimistic. What the testers think, developers are too optimistic. Yes,
Yeah.
testers will always find out some defects. This doesn't work, and it is that the job. So we think that the developers are optimistic, but we are not pessimistic. The testers always find something which doesn't work, and it is the tester's responsibility. Okay, let's go to the levels of independence. So, if you develop the software and if you are testing, then it is your own idea. So, it will have less independence. So, in the same manner, we have to identify the level of independence. So, what is level of independence? The person who wrote the code, the person who wrote the code, the person who wrote the code, if the same person is testing, then there won't be any independence, and the person won't find that many
Defects.
defects. Good. Another person from the development team, another person from the development team. So what happens with this one? You are a developer and another developer is there. You are testing other developers' work, then you will also find less defects because you are testing the colleagues' work and you will have a mindset of a developer. Yes,
Yeah.
but it will have little bit more independence than the person who wrote the code. A person from a different group. Yes, as for example, in an organization, you have an independent test team. Yes, test team. Test specialist you have, but they are separate teams. So it will have more independence than the above two. And the last one is a person from a different organization or a company. A person from a different organization or company. It will have the highest level of independence. How? You work for organization A, yes, and I work for organization B. And if I test your code, I don't have anything to do. I don't know you at all, yes. So what happens? I don't have any relation, so I will find more defects and unique defects than the above three find. As for example, you are a developer, other person is developer, so you will have some good relation. So they'll say, okay, let it go. A person from a different group, but you are working in the same organization, so you will have high yellow relation even. Yes. So that also prevents to find unique and identify some of the defects. But if you are testing a software of another organization, you will always think and find unique defects if you work in a different organization. Yes. Any question
No.
with this one?
No.
Okay, so whenever we find a defects or a failures, we have a different viewpoints. Yes, points for the defects we find. So what are the viewpoints? You are a tester, and if you find a defect, what do you think? A tester. And if you find a defect, what do you think? A job well done. Yes, a good job. Yes, agree?
Yeah.
You become happy as a tester when you find defects. You are testing something, okay? Some small module even. And if you don't find a defect, you will feel that, oh my God, I can't find a defect. You will have this kind of mentality
Mm.
because we believe the software should have defects. It should contain defects. It should not be without defects. If you don't find it, you will feel that you have not done your job satisfactorily. Time and money saved.
Yeah.
Time and money saved. How? Because if the defects is missed, it will go to the production. Then if it
Yeah.
goes to the production, it will come back to you. Then you do all this work. So it costs more money and you need to spend up more time. Yes.
Yeah.
Reduce risk. If you find defects, then it reduces the risks of the application. Yes.
Yeah.
But as a developer, they think in a different way. Criticism of their work. Yes. The developers think these testers are criticizing the work. And they also think that they are criticizing themselves. Yes.
Yeah.
But in these two phases, we have to document all the failures found. If you don't document it, it might come back to you as a tester that, okay, this is not a defect. Yes?
Yes.
Any question?
No.
Let's go to the next point, possible approach. So, what are the approach we can use in testing or whenever you find you will have a class? Yes, because the developer's mindset is different, tester's mindset is different, testers think in a different way, tester think in a different way. We have totally opposite viewpoints. So we have to avoid the class kind of situations. Yes. So what are the approach we can use? One, promote collaboration, not battles. Yes. If you find a defects, you don't say that, oh, you are making mistakes, this and this. No. It's a collaborative work. You need to say the common goal is to produce quality software. So next one is remind all of the common goal, better quality systems. Communicate failures found in a neutral, fact focused way. Whenever you find a defect, you don't need to target the person, you need to evidence it. You need to gather all the evidence and report it in a way that you are just providing the facts of the functionality, not on the individual. Yes, communicate failures found in a neutral, fact focused way. Do not criticize the author. If you find a defect in a code, if you find a defect in the requirement, if you find a defect in a test case, do not criticize the person who wrote it. Yes, do not criticize the author. Understand
Yeah.
how the person feels. You need to understand, you need to put your foot in the shoes, yes, in the person's shoe, we can say. So you need to understand the other person's feeling, understand the feelings of other person. Try to understand why they react as they do. Sometimes when you find a defect and you raise it, sometimes the developers get angry. If they get angry, you need to try to understand why they are feeling that. Yes, try to understand why they react as they do. Yes, and the last one is confirm the other person understands what you have said. Whenever you are passing any information, whenever you are passing any comments after review, you need to confirm that the other person understands. Always cross
Mm.
check with the questions. Did you understand it?
Yeah.
Do you have any questions like that the other person understands what you said? Any question?
No.
Okay, last is what makes a good tester. And with this one, it will end a chapter. If you want to be a good tester, what are the qualities you need to have? One, curiosity. If you're not curious, then you can't be a tester. You need to know how the software works. You need to know how this is going to work. Yes,
Mhm.
but as a tester, you need to be professional pessimistic. Yeah, you need to have the approach of professional pessimism, not in your life. Yes,
Yeah.
you are a tester, so you need to think the software contains defects. Software won't work. Tend to look what doesn't work, and you need to find the defects. So you need to be pessimistic. A critical eye. Your eye should be critical so you can find
Different.
defects, failures. Attention to detail. You should be curious, and your approach should be to know the details of any software. So you can pay attention to details. Always you need to find out everything, whatever you are working in detail. Good communicator. You should be a good communicator. If you are a good communicator, then you will be able to communicate what defects you found. Yes, that doesn't mean that you need to know more English, better English. Yes, the way you communicate is more important. This
Hmm.
defect you found, and you go and tell the developers that these are the defects you found. Yes, that will do. Any questions so far?
No.
Okay, this is the end of chapter 1. So let's move to the chapter 2. Yes. So what is the chapter 2? Chapter 2 is about testing through the software development life cycles. Testing through the software development life cycle. So as per the new syllabus, V model is included. So we will discuss V model. Okay. There is an waterfall model as well we discussed during the overview, but it was taken off from the syllabus. So what is V model? So you can know there is a two phases of testing in V model. One is for verification and another is for validation.
Validation.
Yes. So the typical V model or sequential model, it has some characteristics. They're like all requirements clearly specified. You have all clearly specified requirement. Okay. Yes. Next one
Yeah.
is requirements progressed. All the requirements progress the same time. Yes. All requirements progress. How we will discuss it. All requirements delivered. So how does it work? So I can explain you step by step. So I need to paint like V kind of thing. Yes. So there is an arrow like V shape. So first thing when you start a software development, you have the detailed design specification low level. It talks about unit. Yes. So for that you have component specification. Yes.
Yeah.
Specification. For component specification, you do component testing. There is a terminology unit as well for component. This is mostly done by the developers. Now you have the small components, so you need to integrate them. Yes, and you go and prepare a module. So then you have technical specification. Yes, technical design specification. You can say design specification. So for that, what you will do? Component integration testing. Something going wrong with my testing. Yes. The above that you have the system design specification. Yes. System design specification. So for that, what you do? System testing. Then you have interface specification. Interface specification. Yes. For that, you do system integration testing. Testing. And in the end, you have business specification. And for that, you do acceptance testing. So let me go and explain you in detail. Component. A single unit or a single component. how it should be built, how it should be developed. A text box is a single unit, yes. So you need to verify, you should be able to enter data in a text box and test it. You have the requirement for that. There is a text box there is a button there, yes. So for that, component testing. Technical design specification. You need to integrate components to build a module, yes. For that, how you are going to integrate it and how this functionality works for the specific module. So for that, you can say component integration testing. System design specific. How the system should perform. Yes. What is the purpose of the system design? You need to keep this in mind, and accordingly you carry on testing the system's performance, system's quality. So the testing you do is system testing. Interface specification. Nowadays, what happens? Not nowadays in testing, you need to integrate two systems to make a whole software. Yes, like if you go to the banking software, you have so many modules that they bunch together to make one whole system. So these are all systems, they are integrated. Sometimes you have software, you integrate that software with other software, even not part of that specific, so you can make it work. Yes, so for that you need to do system integration testing. In the end, how the business is going to use the software, how the end users are going to use the software, that requirements would be there, the functional requirements, it can be non-functional as well. For that you do testing, that is acceptance testing. Yes, so now we have discussed component specification, component testing, technical design specification, component integration testing, system design specification, system testing, interface specification, system integration testing, business specification, and acceptance testing. Literally for all of them, we have to have a plan, test plan. Yes. So how do we call it? For component level, you do testing. It's for that plan you can have component test plan. Yes. Here for hello.
Hi, Brijesh.
Yeah, I didn't even realize how long it got disconnected.
Yeah, just 1 minute ago, I think.
Okay. So let me recapture the same thing. So for
Can you share your screen, please?
oh yeah. Can you see my screen?
Yeah.
Yeah. So for component specification, we do component testing. So for literally all these testing activities we do, we have to have a test plan. Yes.
Yeah.
So for that, we call it component test plan. For technical design specification, we do component integration testing. So for that, we have component integration test plan. Yes. System design specification, we do system testing. So for that, we have system test plan. Yes. Test plan. Interface specification. For the interface specification, we do system integration testing. So for that, we have to have the system integration test plan. We have business specification, and for that, we do acceptance testing. So for that, we have to have the acceptance test plan. Yes, for each and every level we do testing, and for that specific level we have to have the test plan, and they are known accordingly. Yes, the other models are iterative incremental models. So what are the iterative incremental models? In these models, the whole software is broken down into a small pieces, and they are delivered. Yes, so let's discuss the characteristics of iterative incremental models. Yes, iterative. And why they are known as iterative? Iteration means it's a time period. An increment, it increments it. So you deliver part A, then part B, part C, part C, part E, part D, whatever D, E, like that. In the end, you deliver the whole software. So the characteristics, what are the characteristics? One, user reusable subsets of requirements identified and increments. Yes, user usable subsets of requirements are identified. So what happens? What does this mean? The user requirements are there in subsets, we can identify and we work and deliver it, and we deliver in increments, a series of shorter development cycles. So what happens? We use small developmental cycle. Like the V model is there, the whole software is started being, and exactly all the activities are done the same time. Here we do exactly the same thing, but we do in the small phases. How small phases? So instead of delivering the whole software the same time, we deliver a small piece of the software. So this iteration 2 weeks or 3 weeks or 4 weeks, they can be a tiny bit or small part of V model. Yes. In the 2 weeks, we analyze the requirements, we design the test cases, we execute the test cases, we do unit testing, we do system integration testing, everything. Yes. So that's why we have small development life cycles. Software produced by iteration. The whole software would be produced iteration by iteration. The small software A, as I said, then another, another, and accordingly, the whole software is delivered in the end. So, software produced by iteration. Regression testing increasingly important. Regression testing increases and important. Yes, just right. So, as for example, in iteration 1, you say that you have 5 requirements. You tested and delivered it. Yes. In iteration 2, you have another part of software. You are testing and delivering. But in that phase, whatever you delivered in iteration 1, you need to retest. Yes. Why? Because that part of the area will be integrated with the part we are building in iteration 2. So that's why I say regression testing increasingly important with all iterations after first. In second iteration, then third iteration. In third iteration, you need to test whatever you are building in iteration 3, but you need to retest and regression test the stuff we have delivered in iteration 1 and iteration 2. The same thing happens in the fourth 5. If your 10th iteration, then in the 10th iteration you are going to test whatever you are building in that particular iteration, but the test cases of 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, because you are integrating the whole software together. Any question with this?
No.
Increments combine as develop to a form a growing partial system. So iteration by iteration, what you do? You integrate the system, yes, to form a partial system, and in the end you deliver the full system, yes. So in iteration 1 you build a small part, in 2 another small part, 3, but you are integrating, and in the end you have delivered the full software. As you are integrating all the functionalities you have delivered one by one, what happens? You need more and more testing. Yes, testing is needed after the first iteration. When you go to, as I explained earlier, in iteration 1 you will test only that bit, but in 2 you will test 1 and 2, in 3 you are going to test 1 2 3, in 4 you are going to test 1 2 3 4. Yes, so that's why more and more testing needed. Some examples of iterative incremental model: Scrum, Kanban, rational unified process, and spiral, or it is also known as prototype. Yes,
So what are all these called? Scrum, Kanban?
yeah,
Are there types of models?
they are types of agile development models.
Okay, this all falls under agile.
Yes, so Scrum, what happens in Scrum? We are using Scrum, but normally you say we are using agile, we call it. Yes, so what is Scrum? The Scrum is a agile type of development model. In this model, what happens? You have a Scrum master. Okay, the Scrum master will manage the team, and in that also you will have the iteration period. It may be 1, it may be 2 weeks, or it may be 3 weeks. Yes, in that particular phase, you will build a parcel system and deliver it. The Scrum Master can be a tester or a developer. Okay, but sometimes the Scrum Master's role is performed, as I said, and he is a tester or a developer. It can be from outside, he might be managing the team, but most of the time, in this, what happens? You have the backlogs. All the requirements are broken down and you put in the backlog. You use a backlog and you have the iteration, you call it sprints. Yes, that sprint is 2 weeks, 3 weeks, 4 weeks, based on the organization and the based on the project. So you say 2 weeks. So during this 2 weeks of period is known as sprints. In that sprint, you select some of the requirements from the backlog and you build and deliver it. You have a daily stand-up meetings. Yes, whole teams get together and do meeting every day in the morning. That is known as daily stand-up meeting. In that you discuss what you have done so far and what you are going to do, the status of the work you are doing, and you are going to provide Scrum reports. In the Scrum reports, you we use Jira, so we can say that all the tickets information or all the requirements details are provided. Yes, any question with this?
No.
Okay, the next one is Kanban. The Kanban is similar It is used for continuous feature development. What feature you are developing continuously, it is used for that. In that we have the agile board, and in that agile board what we are going to use, we configure the workflow. What are the workflows we have? End to end workflow, how the flow works. Yes. So if I need to explain you, how can I explain you? So the process is there, the process goes in the workflow. Yes. So the whole the workflow is built and delivered and developed. Here we don't talk about the backlog. Here we talk about the processes, the whole flow. As for example, I talked to you yesterday about the money transfer. So the money transfer has a flow. Yes. How does it go? The whole flow or the process has been built and developed and delivered. Any question with this?
No.
The next one is rational unified process. It is similar to the Kanban. In this also you are, when you build the process, the requirements are prepared in the processes. Process 1, process 2, the business processes means, okay, and the whole business process is built and delivered in the rational unified process. So the word itself, the rational unified process. So as for example, you work for an energy sector, then it will have meter installation, meter removal, change of supply, cause gain. Change means we lose the supply. Cause, no, cause gain means we obtain a customer. Cause loss. These processes are there. We work on the whole processes, build and deliver it. And last is prototype or the spiral, it is known as. So what is prototype? If you go by the word itself, you can say whatever the actual software, we prepare the prototype of the particular software, and based on that software, based on the model, we deliver it. If I give you good examples, then you say that any building you are constructing. Yes. So for the particular building, the builder will provide you a model. Yes.
Hmm.
That model is prototypes. As for example, when you go out, sometimes you will see some of the photos of the building they are going to apply. Yes,
Built.
outside. So they
Yeah.
will think that these people are working or something. This is a prototype. So based on the prototype, they will prepare, okay, this is what actual software will look like. Based on that, they have the model, and based on the model, they are going to build the whole software. So as for example, this is best for the building construction kind of projects. You know that in software also it works, but construction, you know that they are building multi-story building. So before they make it, they will have the prototype design and everything. They will publish it. Yes. Any question?
No.
Okay, let's go to the next. Do you want to stop it?
Yeah. You can stop it, but can you just repeat Kanban, please? I know it's an agile port after that.
Yeah. So in Kanban, what happens? The whole software is there. For the whole software, you concentrate on a feature development. What are the features of the particular software? The features can be processes. So you keep those features. As for example, I talked to you about meter installation is a feature of the software. Yes.
Hmm.
So it is part of a process. Transferring money is a feature of the software. The functionality, as for example, if you buy a laptop, then what are the configurations or what are the features the laptop has? Yes, you will ask. In the same
Okay.
manner, when you are building, then you say what are the features needs to be built into that software. So the features are the processes. So you concentrate on the particular feature, you build it and deliver it. It can be 1 week time, 2 weeks time, 3 weeks time, or 4 weeks time. Yes. So the feature can be an end-to-end scenario,
And
and it
in
can
the
be
similar
developed
way,
Yes,
the rational unified process is the same.
it is exactly the same way you concentrate on the process, whole process. Here there is a thin difference between process and the feature. Feature cannot be an end-to-end process sometimes, yes.
Hmm.
But when you talk about the process is always end-to-end process. So you say, what is the feature? The feature is going to do bank transfer. Yes.
Hmm.
So the bank transfer is a feature of the software, and when you want to do, you should be able to do bank transfer. But if it is the same thing developed and a unified, then they will concentrate on the whole process, like from where you will start it. So you log in into the system, add someone means add a recipient and transfer the money. That is the whole process. But in the Kanban, you have the feature of transferring money. That is one. Adding a recipient is a feature. So you concentrate on deliver it. How you concentrate on deliver it? What are the processes you need to do when you add a new recipient? Yes,
Yeah.
those things you are going to do. But in unified processes, you don't worry about that one. You have to have whole process, end to end process. For in end to end process, you might have multiple features, but in Kanban you concentrate on the features, so one part of the section, so that is unique and independent feature of the software. If I give you some more examples, meter installation, meter removal is one feature, but what needs to be done when you install a meter? Yes, what needs to be done when you remove a meter? Everything comes as a whole process, and that you will build as a rational unified process. But feature can be a process as well. Okay, any question?
Yeah.
Which one?
No.
Okay, no question. Yes.
Nope. Everything is fine.
Okay, so let's stop it here. Tomorrow can you do class at 8:30?
Yeah.
If you do 8:30, hopefully I will update you, then we can have longer class. Okay,
Okay.
8:30 would be good for me,
Yeah.
but it also depends. My
Yeah.
son got this premier martial arts class, then it would be 9, but still I will finish at 8:30 because here
Okay.
class today, but they sent me a message at 5 o'clock and I didn't even check it. They should have called me, but they didn't call me. So tomorrow, most probably he will have it or might not have it. Okay,
Is
then
it
I'm going.
online or he has to
It's face to
go?
face,
Okay.
face to face. Okay, then thanks.
Okay. Thank you. Bye.
Bye bye.